before we start working with variables, it's going to be good to take some time to see kind of a little bit deeper what you can do when creating variables. So we're going to start with that. First of all, we're going to clean up some of the, the debris we've left behind here. So we'll delete this comment, and then we're going to delete the text inside of our main method. I'll delete these extra lines. So we're kind of starting from a clean slate here. So we've talked a little bit about variable names, but to kind of go a little bit deeper as to what you can put in a variable name. In Java, we accept what are called Unicode characters. So this includes your English character set and a lot of other symbols. We don't want to be too specific with what you can and can't use, but you are allowed to use any letter, lowercase a to lowercase z. I'll do this as a comment so we can see them all. So anything from A to Z, capital A to capital Z, the numbers 0 through 9. You are also allowed to use an underscore or a $sign in your variable name. The only rule is that there's I would say two rules. One, so you have to use all these letters, right? All these different symbols. You can't use anything else, for the time being at least. You cannot start with a number. So you can start with a letter, you can start with the $sign, or you can start with the underscore. And you cannot only be an underscore. So that would be the other rule. Cannot only be underscore. So for example, I could say int a equals 8, and that's okay. I could say b equals 8. I could say underscore a equals 8. But if I try to make it just an underscore, I get an error message here. So I can't do just an underscore, but I can do underscore a. I can do $sign a, no problem. And if I do just a $sign, looks like I'm good there too. So we can't do an underscore by itself, and we can't do a number by itself, and we can't start with a number. So 4a would be bad, but a4 is okay. So those are the rules with naming your variables. Again, generally it's a good idea to avoid numbers unless you have to, and it's always important to make sure your variables have meaningful names so that you know what they refer to. So that's one thing to consider, is what can you even put in a variable name. Another thing to consider are what are called literals. Now, starting with the next video, we're going to start doing some manipulation on data, but when you just give a variable a raw value, we call that a literal. So a literal is the same as a raw value, and it's just one, some people might call them bald numbers. There's no operations being done on them, or it's just plain text with no operations being done on it. It's just something that you can easily change from one value to another. And depending on how you represent your data, you might need to do some special work on your literals. So for example, int x equals 4. Okay, the 4 in this case is a literal, it's a raw value. But there's another kind of integer called a long. And I can say long y equals 4 and put my semicolon there. And we're perfectly fine there. Value of raw x is not used, value y is not used. But we can also put the letter L here after the 4. Now, an int and a long are both integers, but an int takes up 4 bytes, while a long takes up 8 bytes. And that just means that a long can hold a larger value than an int can. So we could also put the L here And it doesn't like it here because you can't put a long in an int, but you can put an int in a long because of the size difference. Kind of like you can't put something too big in something too small, but you can put something too small in something too big. So that's why the L is optional on the long here, but L will not work for the int. So L is how we say, hey, this is definitely a long rather than an int. Another thing to keep in mind is representation. And so this is something that we might talk about later kind of in more detail, but bases are important. There's base 10, base 2, base 8, and base 16. These are all the 4 common bases that you'll see in programming. When you write a number like this 4, that's 4 in base 10. If I were to write the number 11, that's the number 11 in base 10. So in base 10, 11 is 11 just like we think about it. If I were to prefix this with 0b, Java likes that because it treats it as base 2. Now in base 2, the number 11 actually represents the number 3. And if I led with O11, I'm actually in what's called base 8 or octal. Base 2 is called binary, base 10 is called decimal, base 8 is called octal. And the number 011 in base 8 is actually 9 in base 10. And finally, we can also represent it as base 16 or hexadecimal with OX11. And OX11 would be the same thing as 17. So these are all just different ways of representing numbers depending on what kind of application you're writing or what the context of your data is. This is going to be important, but just know that if you see OX, it means this is actually a number just in hexadecimal. If there's a leading 0 by itself, hey, this is actually octal. If it starts with 0b, it's hey, this is binary. And if there's nothing in front of it, then it's just base 10. But these are the 4 major bases you will see and how they can be represented. We also have separators, which kind of help us out. So I could make X be 1,000,000. And I think that's 1,000,000, but I have to count zeros. When you get longer numbers like these, Java lets you just put underscores in the number to break it up. Now it's more readable and I can see pretty immediately, hey, that's 1,000,000. And it's just a way to break up the number. I could put those underscores wherever I wanted if for some reason I wanted to do them between every number. That's perfectly fine, but not really helpful. And so this is kind of meant for breaking up a number into the usual method. And if you see these underscores, that's what that means. And so these apply mostly to integers here, but now we can talk more about doubles. This comes up with doubles a little bit more often. If I wanted to say a number in scientific notation, for example, 1.56 times 10 to the third, which would be the same as 1,560. I could do that in Java. Now for this, it's maybe not exactly ideal, but maybe it's 10 to the 30th. Now that becomes a little bit more tedious because I have to add on, another 27 zeros here. But what we can do instead is in Java we can say 1.56 capital E 3. And what this does is it says, okay, this is a number in scientific notation, and it is a way to kind of compress it down for us. So if you see the capital E here, that's the same as times 10 raised to. So that 1.56 times 10 to the third is 1.56 E3. And the number after E is just this power of 10, and whatever number you put before the E is whatever number is here. So it doesn't have to be strict scientific notation. For example, this would work just fine, and that's not a strict scientific notation number there. The last symbol you might see in literals, and this goes back to floats. So we've said before that doubles and floats are both measuring floating point numbers, and we could write them both like this. And these are both floating point numbers, so the same floating point number, but the float gets angry when I do this. That's because when you do a decimal number like this in Java, Java automatically assumes it's a double. For example, if I just did 5, Java's fine with that because it can treat an int like a float, but not vice versa. But when I add the 0.6 here, it's not happy. This is like with ints and longs. An int takes up 4 bytes, and a float also takes up 4 bytes. So ints and floats are both 4 bytes, but longs and doubles are 8 bytes. And it's the same problem as before. You can fit a small thing in a big thing, but you can't fit a big thing in a small thing. The decimal number is always assumed to be a double. So this is me trying to fit 8 bytes into something that's only 4 bytes big. The way we tell Java, hey, this decimal number is actually a float, not a double, is we add an F to the end of it, and it's happy. Right? So those are the common symbols you'll see. You'll see L, F, E. You'll see underscores. You'll see 0b. You'll see just 0. And you'll see 0x. And these are all helpful in making your literals. So remember, L is for a long, F is for a float. E is if you're writing something in something like scientific notation. Underscores are just meant to break numbers up so you can read them more easily. 0b means the number is actually in binary. A leading 0 means the number is actually in octal. And a 0x means the number is actually in hexadecimal. So that's kind of the overview on literals. And the last thing to talk about in this video is going to be something called escape codes. And we're going to run some code here to kind of see what this looks like. And I'm just going to go to my system.out.println, and I'm just going to put a string in here. In the last video, we only put variables in our println statements, but we can actually put text or raw numbers here. So literals can go here as well as variables. So I can say, this is some text, and I can run this, let it run, and then there's our output. There are a few escape codes, which are special characters that tell the text to do something a little different. One of these is a tab. So in text, right, I could put a tab here like this, save it, and let's see what happens. Okay, and it prints that tab. But a tab like this isn't great because on my computer you can see it's actually 4 spaces. But there's actually a special character called a tab, and the way you write a tab is \t. And that says, hey, put a tab here instead of a \t. In fact, anytime you see a backslash, that's telling you, hey, this is an escape character. This is a special character that's going to behave a little differently. So when I run this, notice I got a bigger gap here. That's because on this line, that's actually 4 spaces, whereas on this line, it's actually a tab. So that's one escape code. Another escape code you'll see is called a new line. And a new line is a \n. So this is actually like writing 2 separate println statements in one. So I'll show you what this looks like. We get run. I get this is some, and then there's space text on the new line. If I wanted to do this just kind of the hard way, I would write it as 2 statements .println space text. I put an extra I in there. We'll get rid of that. We'll run this again, and you'll see we get the exact same output. So that's the tab in the new line. And maybe I want to add some quotes. The problem is we use quotes to say, hey, this is what a string starts and where it stops. So I can say, I can write something like this, but notice Java doesn't really like it because it thinks the string ended here, and it thinks this is a new string, and then it thinks this doesn't really belong anywhere. The way I can say, no, I want you to actually print these quotes is to escape them with a backslash. So now Java's actually happy, and if I run it, I get the quotes in here. You can do the same thing with apostrophes, but you don't strictly need the backslashes with the apostrophes. But if I run it without the backslashes before the apostrophes, it's fine. And if I run it with the backslashes, it's fine. The question that usually pops up about this time for most people is, okay, well, what happens if I do this, where I actually want there to be a backslash in the text? It doesn't like that because it knows the backslash is an escape character. It's expecting something after the backslash. Well, the solution to that is another backslash. So we run that, and we get the backslash printed out. So this is just kind of a little bit more of what can you do with variable names, what can you do with variable values. It goes one step deeper than we saw in the last video to give you a little bit more practice with what can I do with these variables. And in the next video is where we'll really start manipulating the data and working with variables in that way. But this is kind of wrapping up just what is a variable, what do they look like, what can you put in them.